Welcome, everybody, and thank you for being here. I'm here to speak today about write maintainable tests with Docker. So I'm gonna present myself. I'm Gianluca Arbezzano. I come from Italy. I work as a SRE at Influx Data. Influx Data is the company behind InfluxDB, a time series database, open source time series database that you can use for IoT or for monitoring. So you can check it out. You can find me on my blog, and I tweet a lot. So if you have any questions or you like to follow what I say, I'm there. And I like to, when I'm not writing the dirty hacks that looks great, I grow my vegetables in Italy. So they are growing so much with this weather now that I'm not going to find them anymore. It's going to be like a forest when I'm back to Italy. And I like to travel for fun and work. I always, in some way, thought that testing was kind of a solved issue because there are so many libraries and so many ways to write functional testing or integration testing or unit tests. People are doing DDD or BDD or whatever. That I kind of thought, yes, we have a lot. We say a lot about testing already. There is nothing more than we can say about it. And I was wrong. I was wrong, and I discovered that I was very, very wrong when I started to do some contribution for Zipkin. Zipkin is a popular open source tracer released by Twitter, and it's made in Java. I'm not a Java developer, but I really like to make a contribution in there because I had a missing things to add. So I started to hack with Java, and I discovered that they use a library, and it's called Testcontainers. And they use it to write their integration test suite and to run the tests over a set of different backends. So you need to think about Zipkin as a UI that stores information inside storages. It stores them in MySQL, in Elasticsearch, in Cassandra, and in others. And they have the same test suite that runs across all these databases. And they just swap the Docker images that it used under the hood. So a couple of years ago, when I started, the ecosystem was very simple. If you was a web developer, you was gonna do a LAMP side with the LAMP stack. So we was doing Linux, Apache, MySQL, and PHP. That was pretty much how it was working. But now it's very different. So I copy-pasted a random images from Google, writing architecture on AWS. So I don't really know what it is. I presume it is like a WordPress cloudy application. But the idea behind this picture is that today we have a lot more integration and a lot more services that we use. Some of the services we use are written by ourselves because we do microservices, and our services depends on services that we write. Some of them are written by teammates that are from other team in the same company. So we just rely on what other people in our company does. Or in another scenario is that we rely on something that is open source and that we download and install, like Kubernetes or like MySQL or Redis. It's something that we don't really control over the version that we are running, but it's something that we own when something fails. So we still need to test the integration point that we have. Another scenario is that it's not a server, it's not a service that we run or we install, but it's a as a service provided application like InfluxDB as a service or Pusher or whatever we use. That it's not in-house, but we rely on a URL and we go over the network to use it. So in some way, the amount of services that we use is growing a lot. The concept of mocking everything doesn't really work all the time, or at least it works because it makes everything easy to prototype. But at some point, we need to test with the real application, with the real dependency. And sometimes we also need to test that the new version of the service that we rely on works and doesn't crash. And with the mocking part, it's very hard to keep the mock up to date and to prevent them to be old and don't work anymore with the actual service. So that's why unit tests are not enough, but we need integration tests. And we need way more integration tests that we will use to run before. So don't come back home to your boss and says in office and says that I told you to don't write unit tests anymore, because that's not what I'm saying. I write a lot of unit tests, and unit tests are great because it makes me very fast on prototyping and writing code, because I can mock the state I want, and I can verify that the end state is good. But at some point, I need more. I need to test with the actual service that I rely on, because that's where stuff starts to fail. That's where I go over the network to reach a service where that I depend from. This is where the problem starts to happen. So about unit tests, as I said, the philosophy and the libraries are well done in almost all the languages. So all the languages, even the newest one, and we have a lot of newest languages, they have a like unit library that helps you to write unit tests. So JUnit for Java, PHP for PHP unit for PHP, unit test for Python, and Go has its testing packages built in the standard library. So I think that's almost done. The problem comes with integration tests. Integration tests are hard to write because there is the concept of orchestration. You need to spin up one or more services that you need to test your code against them. If it's one, maybe it's easy, but if it's more than one, it gets complicated. I saw a lot of people doing something like that in their CI, where they do Docker Compose app-d, and Docker Compose spin ups all the servers and all the containers they rely on, and they do make test integration. And test integration is the command that runs the integration test suite against the containers that Docker Compose provisioned. This is a way that works, but there are issues. The first one is the orchestration, as I said. Docker Compose, it's something that comes from the outside of your control. So you do Docker Compose, and you hope that everything goes up well. Otherwise, you don't have much control. It will just fail, or it will fail partially, and your test will work just half of them and not all of them. So validation is another issue. How do you understand that your service, your test is ready to be run, or it will fail because your dependencies are not ready? For the same reason about why orchestration is hard, validation is also hard as well. You can retry, and pull and see if the TCP connection works, but you are not sure about why. If we move this complexity inside our test suite, we have code, and we can rely on the code to figure out if our services are up and running, if our dependencies are up and running. Flakiness is also another use case, like controlling all the chain of dependencies from the outside makes the test flaky because they can fail. You don't know if the dependencies are ready. And there is no parallelization because with Docker Compose, you spin up a bunch of containers and you run your application against those containers, but you don't recycle them. They are not isolated by test. There are tricks that you can use. I know that people create MySQL databases per test, so they can point a test to a specific database and load their test suite and their fixtures and do their assertion on that database. In some way, this solves parallelization, but it doesn't work for all the services. There are services that doesn't have the concept of databases, so you have just a big bucket, and you can't really override or change databases. So I think we can do better, and what I discovered with the Zipkin project is way better than that. So we need to remember that Docker has an API. So when we do Docker, when we run the Docker CLI and we do Docker run, we need to remember that there is something that we reach to from our CLI, from our command. It's a daemon that runs in our laptop. It's called a Dockerd. And it gets the request from your Docker CLI, and it does what you ask for, and it returns the answer. So that's it. So the idea is to use the Docker API to spin up our testing environment inside our test itself and run our clients to the set of containers that we spin up. So if you need to think about the Docker architecture, you can think about it in this way. So it's like an onion. So it's a set of cycles that includes functionalities. The overall one is the Docker CLI. So you have this is the one you use. But as I said, behind the Docker CLI, there is a Docker daemon that works as a REST via TCP or via Unix socket. And it manages the network, the container, the images, and the data volumes, and everything you do via Docker CLI. If we go deeper, Docker D, the daemon, the architecture is not, it doesn't manage everything. Like inside Docker D, there is another daemon that is called Docker ContainerD. And Docker ContainerD is a release of ContainerD. ContainerD is a CNCF project that you probably know. And this is the architecture that you find in containerd.io. So the idea is that you just need to think about it as a way more complicated architecture than what we usually have when we do Docker CLI. And all the API that are exposed by the chain of tools we use can be reused. And if something that you are looking for is not exposed, doesn't mean that you can do that. It doesn't mean it just means that maybe it's not a common use case that you need to implement yourself. So Docker in Docker is probably the first way you realize that there is a lot more. So you can run a container that communicates with other containers and spin up other containers. So the way to do that is to share the Docker socket, that is the Unix socket that the Docker CLI by default looks for when it communicates to Docker D. And if you share this volume from your host to inside the container, from inside your container, you can communicate with Docker D. So this is what a lot of CI pipeline does. So Travis CI, Circle CI, Jenkins does that as well. So you can configure, you can share the Docker volume inside the container. You run the container, the test inside the container, you destroy the container, and everything goes away. You can also expose the Docker daemon has a TCP endpoint. So by default, it exposed a Unix socket. So that's why it's var run docker.sock, because there is a file and you can communicate with the file to the socket. If you need to reach to a container, to a Docker D that is not inside your laptop, you can expose the Docker daemon via TCP, and you can reach to the server from your Docker CLI, just doing Docker CLI minus endpoint and point it to the IP of the Docker daemon. But this is just an introduction to tell you that there is a lot more than you can do, and Docker is super flexible because it has this API that you can use. So don't stop about just running Docker run or Docker remove, because there is a huge ecosystem that you can build just extending the API capabilities. This is something important to remember, is that Docker D, since a couple of versions ago, if you don't configure it properly, it runs as a root. So if you expose Docker D in this way, and people can become root or can use Docker D has a root. So you need to remember that it's not super secure. You shouldn't leave it publicly open. Inside the network, maybe it's good, but just to be clear. As every library, Docker also has its set of API. So it's set of SDKs. It's clients that are generated and you can by the community, and that you can be used. That you can use to do whatever you want. So this is the Go version. I write all day in Go, so I have some Java example, but mainly it will be Go related. So this is how it works. You have the context, and you spin up the new client. It is the Docker client, and you configure it. You negotiate the version of the API, and you can do image pull, or you can do run container, or you can do remove image, or whatever you want. So whatever you do from the CLI, it can be done programmatically from the SDK. And this is the key of everything, because it's super important. It opens a world when you remember that you can use the code to control everything. So you can programmatically provision your integration test. So the idea is that you are not going to rely, this is Python code, you are not going to rely on Docker Compose or to an external orchestrator to get your containers for the tests you are running, but you are able to spin up your containers from the test itself. So all the tests will spin up the containers they need, and they will tear them down at the end of the test. So every test will have its own set of dependency ready to be used. So in this example, I'm creating the MySQL container from the image MySQL 5717, and I'm executing a SQL query. Looks like magic. So it's magic, but this is what Testcontainers does. So Testcontainers is a community of libraries. There is libraries for a lot of languages. Java is the most famous one because it was the first one, but I made the porting in Go, and there is a Rust version or a Scala version and other of them. You can check them out and see if there is your language. But you need to think about them as a wrapper around the Docker SDK. So everything can be done. If it's not in your language, you can hack on it. So a way to be in touch with the community is via Slack or via Twitter. So just send questions, or you can open issues, or you can send pull requests. This is how testcontainers.go looks like. This is the test I wrote to check that the Nginx images returns 200. Obviously, your test will be way more complicated, but this is good to have an idea. So you do container, you configure your container, and my container used the Nginx image, and it exposed the port 80. When you expose a port, you are not doing what you are used to do with Docker run -p 80 semicolon 80, because you are saying that the port 80 from the container is the port 80 to the outside, to your host. What you are doing is more like -p 80. So Docker will look for a randomly open port in your laptop and will expose the port 80 for the container to the host. So it means that with mapped port, so with the line nginxc.mappedPort context 80, I'm asking for the port mapped to the port 80. So in this way, we can avoid port collision, even if we run 70 Nginx server that expose the port 80, Docker will remap them to a free port in your host. So you can have all of them running in the meantime. You just need to remember that there is a limit for the port you can open, but it's a lot. So when we have your container running, I defer the Nginx container with the termination. So I know that the defer in Go, as in other languages, means a function that will be run when the main function is over. So when my test is over, the defer function will terminate the container. So I'm sure that I'm cleaning my environment. And when I have my container, I get the URL, and I do a HTTP GET on the container, to the container, and I check if the status code is 200. That's it. This is super simple, but you can make as complicated as you want, because you are in the code itself. So as powerful as you are, you can do whatever you want. This is the same for MySQL. So MySQL works in this way. So I'm doing a container request for MySQL latest. I expose the port 3306 and 33060 for MySQL, and I can use the environment variable. So as you can see, it looks like a Docker CLI run command, but it's just mapped in the language you choose. So this is Go, but it works in the same for the Java one. So what I'm doing here is I'm not doing an HTTP request because I have the SQL client in Go. So I'm configuring the SQL client with SQL.open to connect to MySQL. That's it. If you use Java, if you're more familiar with Java, this is how it looks like. So this is a test I took from the Testcontainers Java example, and it's using Redis. So I'm configuring a generic container from the Redis 3.0.6 image, and I'm exposing the port 6379. That is the same I was doing before in Go. And I'm configuring the Jedis, that is the Redis client in Go, to communicate to that container on the port that I exposed. So you can see the flavor that it's similar across languages, because this is what the community is trying to do. It's trying to take the same flavor of how the library works. And I'm also doing the assertion about like get from the cache a key and check if it's inside. This is how you exec inside a container. So when you have a container running in Java, you can also do exec, and you can create a file, for example, touch some file, That's what it does. We can expose environment variable, or we can mount volumes. So there are a lot of libraries, as I said, in different languages. Java is obviously the most popular one and the one that has a lot more capabilities. In Go, for example, we didn't import it yet, but we are adding features as people are asking for it. So just ask or made it. This is the same example. Like there is a in Go. This is Java, but we also has this concept in Go. There is the idea that you can wait for something before proceeding, and this is how we solve the validation and orchestration issue. So you have your containers. You configure the containers with a bunch of functions that wait for something to happen before to proceed. So you are sure that your containers are up and running. And just because you are inside your code, if the container never reach the wait strategy because there is something broken, you can keep retrying until you are happy with the provisioning. So in this case, we are using the wait for HTTP to happen. So we are configuring a HTTP client to ping the container until it gets the 200 or 301 from the index. You can also share volumes, as I said before, or you can programmatically build an image from the test itself. So in this case, we are building an image from a Docker file from inside your container. It's something that flies over me. So this is an example I took from from Zipkin and how they test against Elasticsearch. So as you can see that they are exposing the port 9200 from Elasticsearch, and they are configuring the container with generic container image, and they expose the port, and they wait for the path, for the index to be to be ready. They start the container, and they proceed. From there, you have the client ready to go. One of the projects that started from the test containers idea is MobiRayuk. MobiRayuk is a library that you can use to. It's used under the hood from test containers to clean your containers when you are done. So if you don't defer your container, as I showed you before, there is Ryuk that runs in background, and it removes the container with a particular label. So test containers creates Docker containers with labels, and Ryuk removes them after 10 minutes. So in worst case scenario, after 10 minutes, all your containers are gonna go away. The one created with test containers, obviously. Something that you can do now that you have your code and you programmatically manage your container and your test is to write utility functions. So you can write a framework for your application that helps you to write integration tests. This is very critical and crucial because if you can spin up a good library and you can provide a good library for your application, other people will be happier to write integration tests. So do that. It doesn't need to be complicated. It needs to be just enough to make other people happy to write integration tests for you. There is a concept in Java and also in Go that I'm working on that is called canned dashboard, and they are containers, and they are pre-configured for some specific service. So I'm doing in this pull request, I'm doing the MySQL pre-canned dashboard container, and so in this, I show you the example about how to run a MySQL container before. With a canned container, the idea is that you will do the same, but just with one line of code, because it will be friendly and will be easier to do. I'm doing the same for Kubernetes. So I wrote a lot of operator or integration with Kubernetes in my daily job. And with kube-kind container, the idea is that I'm going to use kind, that is a project that is written in Go and is maintained by the SIG testing in the Kubernetes community. And what it does, it helps you to run Kubernetes inside a container. So the idea is that you will be able to run kind from test containers inside your test. So you will be able to get, in this example, this example already works, so it's not magic, this is done. And I'm running a container, and just because it's pre-canned, I have utilities function that I can use. My utility function is get client set. The get client set give me the Kubernetes client, and from the Kubernetes client, I can reach the Kubernetes API. So in my case, I'm checking that the default namespace exists. That's it. This is it. I had a bunch of links to my slides, and I'm gonna share them on my Twitter, or the conference organizer will share them as well. So let me know and come help me with the Go library if you need it. Thank you.